Hello. We're going to find the limit as x approaches infinity of the rational function 3x plus 1 over x minus 2. Now there's a couple of things you have to think about because we're letting x approach very large numbers, infinity. So keep in mind that the symbol infinity is used just to express any very infinitely large number. Okay, so it's not a precise number, it's more of an idea, extremely large numbers. Okay, so because it's a general idea instead of a precise value, you cannot say that infinity over infinity equals 1. It's not equal to 1. And you cannot say that infinity minus infinity is equal to 0. The reason you cannot say these is because the infinities in each of these cases, the different infinities might be different values, different very large values. So you can't say for sure that infinity over infinity is 1 or infinity minus infinity is 0. So we have to avoid that at all costs. In general, we may avoid this idea of infinity over infinity or the idea of infinity minus infinity by doing either of these things when you're taking a limit. The first thing you might try is an algebraic method of resolving the issue. You multiply the rational function by 1 over the largest power of x in the fraction or in the rational function divided by 1 over the largest power of x in the fraction. Now this is just 1. It's a strange form of 1. Another method you could use is you could rationalize the numerator. That might help from getting one of these strange indeterminate forms, infinity over infinity or infinity minus infinity. Now look at this problem. If we went ahead and took the limit directly, we would get infinity over infinity and we wouldn't know how to handle it, so because it wouldn't make sense. So let's take the limit as x approaches infinity. Let's multiply the top and the bottom by 1 over the largest power of x in the rational function. That would be x to the first power. Distribute it across the top, distribute that across the bottom. You get 3x over x plus 1 over x over x minus 2 over x. And that simplifies nicely to 3 plus 1 over x over 1 minus 2 over x. Now as x goes to infinity, the denominators go to infinity, which makes these fractions go to 0. So what we really have here is the limit of the dominant term above over the dominant term on the bottom, the constant. So it's 3 over 1, which is 3. The limit of a constant is a constant. See, what we really actually did, we did it a lot more formally in our mind. We didn't show it all, but we distributed the limit to each of the terms on the top and each of the terms on the bottom. And then we used the limit laws that say the limit of a constant 3 is 3, the limit of a constant 1 is 1. We had a law that said the limit of 1 over x goes to 0. As x goes to infinity, it goes to 0. And 2 over x as x goes to infinity is 0. And that's what we were doing. That's what we were thinking when we did that problem.